Good morning, everybody. How's it going? This is Mr. Louie. I'm here to talk to you guys about Activity 3.1.2c, stacking objects and using roll angles for our computer integrated manufacturing class. So, if you're watching this and you are unable to use the RoboCell and the CellSetup software because you are working from home, then I recommend you look at the Distance Learning Activity 3.1.2c, stacking objects and using roll angles. However, today we're going to talk about the in-class assignment. Basically, the introduction here, take a second to read it, but it talks about how you will need to use what they call degrees of freedom to actually align your robot's gripper handles with the object that you're trying to pick up or stack. In this particular project, you are going to set up your RoboCell to have 3 blocks instead of just one, and then you're going to stack each block on top of the other. Um, so if we continue rolling down, you'll see that they want you to use the RoboCell software. And again, if you need to find it, I'll explain where that is. And then you have resources here. They discuss what roll angles are, the RoboCell planning document, and then kind of a work envelope paper if you are using the actual physical robot arm. So let's talk about the procedure. So the first thing that you guys should do is review this document under step 1, roll angles information. So if you click this link here, it should open up and talk about roll angles, okay? So very briefly, I'm going to talk about roll angles for you guys. So roll angles are basically what they call degrees of freedom. Degrees of freedom are how your robot is able to move, right? So when you think about us physically moving, what are our limitations when we move? When we're turning, when we are stepping forward, stepping backwards? Well, generally speaking, there are usually a maximum of 6 degrees of freedom for a object. You have 3 linear motion degrees of freedom, which just means that you can move in certain axes. In this case, they're saying we can move in the x-axis, it can move in the y-axis, and then it can move in the z-axis. Now, the thing that you guys may not be familiar about is that a lot of times, even if you can move in those axes, you may have a joint attached to those axes. Remember when we were talking about the work envelope of a robot, and they had those different joints that allowed it to rotate, right? So depending on where those joints are, they're going to have a rotation around one of those linear axes. So around X, around Y, and around Z. So the rotation around your X-axis is actually what they call your yaw. The rotation around your Y-axis is called the pitch, and the rotation around your Z-axis is going to be called the roll. So why should we calculate these roll angles? So in a nutshell, basically what this says is you want to calculate your roll angles because the gripper is generally speaking just a two pinching device. Like it has 2 arms, right, or 2 little fingers rather. And if you were trying to pick up a square object, you may be trying to pick it up by the edges if you rotate only around your Z. So what you then need to do is adjust that gripper so that it is going to pinch on the flat sides of your box. And I'll kind of show you that in a second. But basically, in this activity, you'll learn how to calculate the roll angle. And in this activity, it's a lot easier than they make it very basic just so you guys can understand it. But basically, you would use what they call the inverse tangent function to find the angle of a right triangle. So you will use SOHCAHTOA, right? Side, opposite, hypotenuse. For sine is opposite over hypotenuse. Cosine is the adjacent over hypotenuse, or tangent is your opposite over your adjacent. So that is what they discuss here. I do encourage you guys to take some time to actually read through the whole thing. And then I will go through this activity. So the first thing I want us to do is create a graphics in CellSetup. So you guys remember, if you click down here in your start menu, scroll down to RoboCell 2020, you should see CellSetup 2020, which is what we're going to start with, and then RoboCell 2020. So first we're going to do CellSetup 2020. So I'm going to left click on there and open up a new file. When this opens, I'm going to half my screen here so that way you guys can see everything. Okay. So I'm going to hit this top right button to minimize it, and then I'm going to do a Windows L, and that will lock it into the left side of my screen. Windows L. So Now what we're going to concentrate on is actually doing these steps here in step 2. This picture right here kind of shows you what we're going to be shooting for. We're going to have a pedestal robot, which means there's not going to be any sliding base, right? So I want you guys to think of how many degrees of freedom does this robot have? Well, it doesn't actually move at all in this direction, right? It can't move side to side necessarily, but it can pivot. So then it kind of gives it the illusion that it can move in X, it can move in Y, and it can move in Z. So the first thing they want us to do is add a robot with a slide base. So again, when you use this CellSetup software, you just want to click either File New, or you can click this blue page button which says New. And when you click it, it should open up this window so you can set everything up. I'm going to again, and then I want it to be full screen, so I hit this button over here and made it a smaller window. Then I hold down Windows, hit left on the arrow key, and it makes it half of my screen. If I do Windows and hit right on my arrow screen, or on my arrows, then it will make it on the right side of my screen. But since I already have something on the right side, I'll just put this on the left side. So the first thing, like I said, is you're going to add a robot. So you need to find under New Objects, Robots. And then if you double click it, you should open that folder to see that there is a ER4U robot. All you have to do is double click that again, and then under properties, you have no slide base, slide base, slide base. So in this case, they told us we don't want a slide base on it. So we want to say no slide base and hit OK. When you do that, you'll notice that a robot pops up in your environment. So the next thing we gotta do is add a table that's 1000 by 1000. So the table's gonna be under your general tab, and it's the first one there. It starts at 800 and 1500, so you just gotta type in 1000, 1000. Then when you have those numbers correct, hit OK. And then you can see that my icon now changed to a little box with an arrow. So it just asks you to left click somewhere and place your box. So if I put it over there, you can see that it doesn't really line up very well with my robot. So you have to double click what you're wanting to move. And you see that it says table 1. You can rename it, you can rotate it, but all I really want to do is change the position of my table. And you'll notice that where I clicked it was negative 622 in the X direction and negative 1550 roughly in the Y. So if you change to 0, 0 though, because that's the location of the center of your robot, or the center of that square that everything's sitting on, you'll see that that table now is in the center. So the last thing we have to do, guys, is add 3 cubes at these positions. So cube 1 is going to be at x300, y0. Cube 2 is at x300, y negative 100. And cube 3 is going to be x300, negative 200. So your cubes are going to be under materials. I'm going to double click cube. We'll leave it as red for now. It's a 40 by 40 by 40, so that's okay. Click OK. And then again, you're going to do the same thing. You're going to want to click on the table. You're going to have to place this. If you want to zoom in, hold down your right click button and go up. If you want to zoom out, hold down the right click button and go down. So that's one way to zoom in and zoom out. And then obviously you go left and right, it kind of twists it around. But I want to click on this table, and we can see that my block shows up there. So now we want to double check the location of the block. So you double click the block, see that it says cube 1, and hit position. So it's currently at 357.9 in the X and negative 80.9 in the Y. Well, we want this to be 300 in the X and 0 in the Y. So we will click OK. And now we can see that our block is in line with here at 300 millimeters away from that base. So then we have to make another cube. In this case, it's going to be automatically named cube 2. But I will change the color to yellow just so we can have different colors. It's a 40 by 40 by 40. And then I'm just going to click on the table and place it. After you click on the table and place it, you do the same thing. Double click the object that you're trying to move. In this case, you see it's cube 2. Go to position, left click, and then change these numbers to match what they say. So 300 in X, negative 100 in Y. And you can see that cube 1's are here, cube 2's to the left of it. So then let's move to cube 3. Double click cube. I'm going to change the color just to make it easier on us to green. And then it's a 40 by 40 by 40. And it looks like we're going to be moving that way anyway, so I'll place it over on this side. I'm going to double click the cube to check its position again. Obviously, it's not correct. So I'm going to change that to 300 and negative 200 like they told me, and hit enter. So now if I look at these cubes, they should be in line with each other and just kind of spaced out 100 millimeters apart from each other, which looks like that's the case. So now what they want us to do is save this file. So like I said, guys, do a file save as, and doing a save as means it's going to force you to name a file. But if you hit save and it's the first time you're saving, it's going to do the same thing. I recommend you guys clicking this drop down arrow and trying to find your Butler Drive or Butler Tech OneDrive or your Fairfield City Schools OneDrive. Again, we want to start saving to the OneDrive. In this case, my CIM folder is under my Butler Tech. You'll see that I named a folder for this particular assignment or activity called 3.1.2c, Stacking Objects. And then I actually already have one here with the CellSetup, but I'm just going to name it Louis S _ A312C, and then hit this save button. So what I want you guys to name it is basically your last name, your first initial, underscore, and then what they ask you to name it here, A312C. And then since I already saved this, I'm just going to hit cancel, and you guys should hit save. And that's how you guys do the CellSetup portion of this, all right? So the next thing that we're going to do is we are going to actually open up our RoboCell. So again, go to Start menu. You can either type in RoboCell and you can pop up the app that way, or you can do the longer route and actually hit Windows, scroll down to the R's again, and find the actual RoboCell 2020 software. Both things accomplish the same task, guys, so it's up to you on how you want to get there. But now let me talk about this while it's loading. And there it goes. So again, this is kind of too big. I want it to be on the left side of my screen. So I'm going to hold down the Windows key and hit my left arrow on my keyboard, and that will snap it to the left side of my screen. So what I want to do now is we are going to set up different positions. All right. And these positions are going to be set up based on this chart here. So you'll see, rather than having only 5 positions like we did in the last activity, we are going to have 1, 2, 3, 11, 12, 13, 23, and 33. And then we also have 99, which is going to be our home position always. So that's going to be a total of 9 positions, okay? You can see that the block is going to be at 9 different positions. So 1, 2, 3, 4, 5, 6, 7, 8, and then 9. So that's 9 total positions. But our objective here, you can see, is going to be, we're going to start at an initial position. In this case, it's going to be our home position, position 99. And then remember, position 99, they don't tell us that number, so it's just going to be up and away from where our work area is or where our blocks are that we're going to actually be picking up. Then our objective is going to be to stack the 3 cubes on top of each other. It wants us to first stack cube 2, right? So that's cube 2 right here, this red one, on top of cube 3, which is that green one. After we stack that on top of cube 3, we're going to go over to cube 1, move to cube to height 11, move over to 33, and stack it back there onto cube 2. So that is what we need to do. They kind of show you this nice diagram that shows you the Z values. They show you the relative position if you're going to plan on programming this in a relative state rather than absolute. And then you'll see that they actually give you the X, Y, Z, and the pitch for every single number. But the one thing they don't give you is the roll. So the roll that we would have for positions 2 and positions 12, that's why they're both yellow, is the same. And then the roll that we have for 3, 13, 23, and 33 is also going to be the same. And we're going to see that that's going to be dependent upon how far over we are in the X and Y directions, okay? And they kind of give you a nice diagram again to remind you that roll is around your Z axis, and then pitch is going to be around your Y axis. So in this thing, they talk about how the cubes are going to be aligned and stacked by calculating and applying the correct roll angles for those positions I talked about. This little diagram right here kind of shows you the way that you would calculate the roll angle. And then this diagram right here shows you an orthographic view of how you're going to be picking up your block, moving into a certain position above the block, coming across, and then setting it down. So as we continue reading here, they talk about the amount of rotation needed to be found by determining the size of the angle whose tangent is calculated based on the dimensions of the triangle. So don't let that confuse you guys. Basically, what they want us to do is solve for this variable. So if we look at this, we're just trying to find this angle here, and that's going to be what we're solving for. So for position 1 to 2, we can see that we are 300 millimeters up in Y, and then we are negative 100 millimeters in the X direction. So can somebody tell me if we are using the inverse tangent, right? So we're doing TOA, which means that this is going to be your tangent equals, and again, this is tangent theta, equals your opposite over your hypotenuse. Or sorry, adjacent. So you're doing your opposite over your adjacent, not your hypotenuse. Which one is your adjacent and which one is your opposite in this case? Okay, so your opposite, right, should be the one that is directly across from your angle that you are trying to solve for. So in this case, our negative 100 is going to be our opposite, okay? And our adjacent is going to be the number or value that's going to be right next to the angle. So in this case, it's this one. So this would be our adjacent. So when we are trying to calculate for this, we're going to end up doing the tangent, or the inverse tangent rather, of negative 1 of the opposite of our adjacent. And they show that right here. They give you guys the actual formula. So we're solving for the inverse tangent of the opposite over the adjacent to figure out what is our roll angle for this one. So what I want you guys to do is try to use this formula and figure it out. So please pause the video here and then proceed once you think you have an answer to check with what I have. All right, so like I said, hopefully you guys pause the video, but I'm going to show you the calculation for this one and then let you guys do what you need to do for the next roll angle. So we're doing the tangent of negative 1 of our opposite over our adjacent, and that's going to equal theta, which is going to be our roll angle in this case. So if we take a calculator and actually plug in our numbers, it's going to be the tangent of negative 1 over, again, our opposite's the bottom number, so negative 100 over 300 millimeters. And again, technically speaking, we would want to write our units, but since our units are on both the top and bottom, they actually cancel out. And then when you actually calculate this number is going to end up equaling, let me get my calculator here, it equals negative 18.435. So theta in this case is going to equal negative 18.435. And because it's an angle, right, it's going to be degrees. So that's what we're going to do for this one right here. So then the next thing that we're going to talk about, or that they do, is actually finding the roll angle between position 1 and position 3. So you're going to do the same exact thing, figure out which side is your opposite, which side is your adjacent, and then find your roll angle, for, or theta 2 in this case. So after you calculate those roll angles, then you are going to modify the program to determine if everything lines up. So let me show you guys very quickly what mine looks like. And based on what you learned from the last time, you should be able to actually do this, the rest of this activity by yourself. So I'm going to go to my OneDrive, and again, I did this already. So I have a file that's going to be named my last name, my first initial, underscore A3.1.2c. And you'll notice that the file type is called a project file type. So that's where the confusion sometimes came from, you guys. Make sure when you guys are trying to make this file, you're importing your cell object file. I'll show you guys how to do that in a second. So right here, though, I want you guys to, there we go. So if I do run, and I can actually run mine continuously, there's going to be a little bit of, I want you guys to try to see if you can get yours to run continuously, which means you're going to have a few more positions than you had last time. But basically, If I do run here and run continuously, my block should be taking the robot, going over to block 2, picking it up, going above where block 2 was, moving over to block 3, and setting it down. So you'll see though that that gripper arm never actually changes. It was always staying flat or perpendicular and parallel to the sides of my block so that it can pick it up precisely. However, if I didn't add a roll angle, it would not be able to do that. What it would be doing is it would be trying to grab those corners instead, and obviously that would not be a very secure situation. So you can see right now that my robot now picks it up, stacks them up, and then it puts them back to their original position. And since I have my program doing that, when I run it continuously, it's going to recycle all the way back to my original top of my program, and then pick up block 2 again. Okay, sorry, it's going to go home and start from home position, go back to block 2's above block 2, come down on block 2, pick it up, come back up to where block 2's pickup position was or position, and set it back down. And then it can continuously run this because I have it to where it's resetting the position of those blocks. So I want you guys to kind of figure out how can you do that as well. Yeah, I know they don't say that in this, but I think it's kind of a neat way to practice. So again, your goal is to program this, and I'll have another video that kind of goes into the details of doing that here shortly. But let's stop that for now, and I'm going to do a new file just so you guys can remember how this works. So under new file, the first thing you want to do is go to options and make sure you're on simulation. If you're not on simulation, then your robot will look kind of funny, right? So let me do this. Go to file, import 3D model, and you want to find your cell setup. So again, I saved in my Butler Tech Sim folder under stacking objects. You should do something similar so you know exactly where it is. If I hit open, there's my cell setup here, and you can see that it's already in kind of this angled position. But if I go to options and do offline, it won't let me run anything anymore, okay? So I want you to make sure that you all have simulation on, and I want you to do options and go to pro level. Pro level is going to give you guys more commands over here on the right-hand side when you're trying to program your robot. You obviously see that this window is very congested right now. So if you want, you can go to window and simulation and teach, and that will kind of reorganize these windows so everything looks a little nicer. All right. So just like this says, the first thing they want you to do is type in your last name. I want you to add your first initial and then do A3.1.2c as your program. So after you have this all set up, you have your robot imported, do file, save project as, and then name it like this. Mine is Louis S underscore A312C, and it's going to be a project file. When you're done, you hit the save button here, and then it will save that program. So that way, when everything that you change in this program will be saved as long as you start to hit this save button, whether it be this floppy disk or you can do file save project. If you hit save as again, it's going to make another project. So make sure you just do the save after you name your first thing. So now we're on step 5. We already opened up RoboCell. We want to go options and select Pro, which is what I just told you guys to do. We imported our 3D graphics file. So now we're going to add our 4 remarks. So again, if you look at your commands down here in the bottom right where it says workspace, I'm going to click the commands tab. And then under program flow, we should be able to find remark. So if you double click this, then it'll pop up on a screen that says remark. So the first remark is just the activity. So it's Activity3.1.2c, stack roll is what they call it, and then hit enter. You'll see in our program up here, we have that in there. So the other thing you can do, right, is you can type in the 2 letters in front of it to do kind of a shortcut. So in this case, if I'm over in my program window, I can type in RE and make another remark. So I'm going to type in my name, Mr. Louis, hit enter. Again, I'm going to hit the keys R and then the E key, and then it's going to open up another remark. So it's period 2, hit enter, and then enter the last remark. So today's date is 4/12/2022, hit enter. So there you go. I have my 4 remarks for this particular thing. So then the next thing we're going to do is use the teach method to establish the required positions. So the way you guys do this is up to you. Obviously, you have a little more experience with it now if you did it previously. But what I'm going to do is show you guys how to do the first 1 or 2, and then let you guys kind of make your own decisions on how you want to go about programming this guy. So first things first, you can't hit this get position button. You're going to get a error unless you actually assign a program number. So the first thing you're always going to want to do is go on the position number here and type in your position. So I'm going to type in position 99 first because my robot's already at a position that I feel like is a pretty good home position. So after you type in the number that or the position number that you're going to try to make, you want to click this record position button. So it looks like the robot with a little red dot. Click that. And then if you click the drop down, you should see that 99 is now a saved position. So when you have a position number, you can hit this get position button. It's lagging a little bit. Give me a second. There you go. And you can see that my current X, Y, and Z is X at 169, Z at 504, and the pitch is negative 63.55. So I don't necessarily want that to be where my home position is. I mean, it's not a bad home position, but I'm going to try to just round up the numbers a little bit. So I'm going to say, let's move to 175 for X. We'll go to 500 for Z. And then I'm going to go to negative 90 for our pitch angle. So after you change these numbers, right, the way you do a teach position like they want us to do is click teach. And after you teach, you want to actually physically move to that position. So your robot may know where the position that you're trying to move is, but until it actually moves there, it's not going to be able to record the correct position. So hit this move button. You should see it move a little bit. And then if I hit this record button, now position 99 is going to always come back to this position at 175, 500, and negative 90. If I hit get position, your numbers might be a little off. Yeah, but that's just kind of how this program works. It's kind of a little glitch in the system. So there we have my home position, okay? So then the next position that I'm going to program is position 1, and then I'm going to program position 11. And then when you're already at position 11, guys, it's going to be easy enough for you guys to position 12, and then 2, and 33, 23, 13, and 3. So again, I would just kind of program it as you want, but using this table on the right-hand side is going to be a big help for you guys. So let's just go ahead and program position 1. We'll just go in order for now. So when you want to program a new position, you type in the position number, and then you hit record position. So when you hit record position, if you click the drop-down arrow, when it pops up, we'll see that I have 2 positions now, position 1 and position 99. But if I hit get position, nothing's going to change because when I hit record position, that robot was at the same location as it was before, as position 99. So now this is when you want to start typing in your numbers. So it says that in the X, we have 300. In the Y, we have 0. In the Z, we have 17.5. Our pitch is going to be negative 90, so we're there, and our roll is going to be 0, so we're there. So again, we're just going to change these numbers to match. So 300, 0, 17.5, and then we hit teach. So remember, we want to be on position 1 when we're doing this, and then we change all these values to match what they want us to be at, and then hit teach. You can see down here they have an absolute and a relative to. So right now we're only doing absolute, but relative would be like if we knew our position in the X and Y from our home position, right? Think of it like incremental when we're doing G coding. But we're going to do absolute right now because absolute is what we're given. So I already hit teach. I put in all these numbers. So if I hit this straight arrow, it should move the robot to the correct position. Now, I'm pretty sure my grippers are closed, so when I click this, it's going to go to that position, and it's going to end up hitting this red block because it's not open, and it's going to give me an error. Position error, the motion is too great, or impact has occurred. So I'm going to hit OK, and on the bottom left here, you can see there's a manual way to open your gripper and close your gripper. So the open gripper is this icon, the close gripper is above it. So if I hit the open gripper button, it's going to open it. And then if I hit the position button again, it'll move down to the right position. So now you can see that this is where position 1 is. But if I don't click save position yet, and say I go to 99, and I go back to 1, and I hit this button, actually, apparently it does save after you hit teach. So you don't have to hit record position again. As soon as you hit teach, it's going to know what position you want. But if you really want to make sure that it's going to keep the position that you typed in, I would just recommend hitting the record position button again after it gets to the location that you want it to be. So let's double check that though. Let's move to position 11 next, since that's going to be our position after we pick up the block, which is right above the red block. So I'm going to type in 11, and I'm going to hit this record position button. All right, so now I have 3 positions, 1, 11, and 99. So if I look at the numbers for 11, I have 300, 0, 157.5, negative 90, and 0. So 300, 0, and then our only number that's different is this Z value. So it's 157.5. So if I hit teach, I move to that position, you can see that it goes above my red block. So that's going to be our intermediate position. As we pick up the block, we're going to move here, move all the way over to where our stack of blocks is, and then come down and set it down. So if I go to position 1 and hit this straight arrow, I should be going all the way back down to my block. And then if I click on position number and go to position 11 and hit the straight arrow again, I should go above my block. So you can see that as soon as you hit that teach button, it is overwriting that original position that was in this position number. So now let's do one of those ones with the roll that we calculated. So if you guys remember, and let me roll down here, the first roll angle that we calculated was negative 18.435. So that was between positions 1 and 2 here. Okay, and positions 1 and 3 was negative 200. So this is going to be for positions 2 and 12. Is what position or what theta 1 is. So what we're going to want to do is type in position 2 or 12. In this case, like I said, I'll do 2, hit my record position button. So now I should have 1, 11, 2, and 99. So with 2 highlighted or selected, I'm going to fill in this column. So the yellow box here, or cell, is the one that we just calculated. It was negative 18.435. So I'm going to type in negative 18.435, and I'll type in the rest of these numbers. So 300 and the X, negative 100 and the Y, 17.5, and the Z, negative 90, and the X, and the pitch. So if I hit teach, and I go to that position, you'll see I have an impact. The main reason why, guys, is because I did not go to position 12 first. And that's why it's very important that the sequence of numbers that you choose. So it's not going to let me go past that right now. So then, while we're at it, why don't we just go to position 12 real quick, record this position. So position 12 is going to have the same roll angle. It's going to have the same pitch. It's going to have the same Y and X, but it's going to have a different Z value here. So you can see that the Z value is 157.5 instead of 17.5. So I'll type in 157.5, hit teach while I'm on position 12, and then click this arrow to go to that position. Now that we're up here, I can go down to position 2 and hit this arrow, and we should be able to pick up the yellow block. Good. So I've already kind of showed you guys how to do 5 of the 9 positions. So with that information, you should be able to figure out the last positions, which are 33, 23, 13, and 3. They give you all those numbers. You're just going to have to calculate the roll angle based on step F here. So this is where you find the roll angle for positions 3, 13, 23, and 33. Again, you're going to basically be doing the same thing as what we did above here. Find the inverse tangent of your opposite of your adjacent. And then the last thing you guys would have to do is actually program it. So again, please remember, I want you guys to try to program this to where not only does it stack the blocks up like it tells you in step 4, where you stack cube 2 onto cube 3, and then you stack cube 1 onto cube 2, but then I want you to return them back to their original positions, so that way you can continuously run this cycle. Obviously, there may not be a point to doing that in a industry. Like if you're working in industry, you don't usually stack something in and put it back. But because we want to be able to run this continuously, so think of that art exhibit that we were talking about, where it's the robot trying to pull all that hydraulic fluid back to itself, we would need to have that work. So please try to work on that, guys. I'll look at it some more, but that should give you guys a good start. I do want to just mention, if you change this roll angle to 0 and hit teach, you can see that the angle of this gripper would not be in an ideal location for picking up this yellow block. You can see it's kind of angled, and that's why you need to calculate this roll angle. Okay, so have a good one, guys. I'll be around. If you need me, just message me via email, remind, or obviously in the classroom.